You've probably seen holograms in sci-fi movies or maybe even in real life. They are three-dimensional images that appear to float in space, without the need for glasses or any other special equipment. It's a really cool concept, but in reality, holography has been pretty limited in its applications. One reason for this is that traditional methods of producing holograms require supercomputers and can be time-consuming, making them impractical for widespread use. However, recent advancements in deep learning and tensor holography could bring holograms within reach for consumer-grade hardware and lead to a spillover of holography into fields like VR and 3D printing. Holography is making a comeback thanks to AI. Invented in the 1940s by Dennis Gaber, holograms have joined forces with deep learning to enrich the virtual world experience. Massachusetts Institute of Technology published a research in 2021 that demonstrates a new method of generating holograms using artificial intelligence to create holographic content in real time. This new method is called Tensor Holography and can run on smartphones and laptops. The MIT researchers made the machine learn physics independently while not sacrificing the photorealistic nature of the output. The researchers used physics-based calculations. To create the holograms in the new database, they used scenes with complex and variable shapes and colors and the depth of pixels, which are distributed evenly from the background to the foreground. This approach, stated researchers, resulted in photorealistic training data and hence a workable algorithm. The fully optimized tensor network operated orders of magnitude faster than physics-based calculations, crafting holograms in mere milliseconds from images with depth information calculated from a multi-camera setup or LiDAR sensors. This advance paves the way for real-time 3D holography, which could enhance a slew of systems from VR to 3D printing. Additionally, 3D holography could boost the development of volumetric 3D printing, the visualization of medical data, and the design of surfaces with unique optical properties. Microsoft HoloLens and Facebook's Reality Labs are two of the big names at the forefront of augmented reality research. They have demonstrated that they can change how we do product maintenance, education, entertainment, and even high-precision surgery. For instance, the Belgrist University Hospital surgeons have used Microsoft's augmented reality in spinal surgery. The surgeons used the generated CT imaging and the 3D representations of the affected anatomy directly projected into the surgical field, overlaying the real anatomy during the operation. Throughout the surgery, the surgeons were prompted for various actions such as the exact insertion point and trajectory of a screw. In a nutshell, tensor holography is a way of creating much more realistic and detailed holograms. The key difference is that traditional holograms use just one type of wave, typically light, to create the image. Tensor holography, on the other hand, uses multiple waves, which allows for much more complex and detailed images. The technique is based on something called tensor calculus, which is a pretty complex mathematical concept, but basically, it allows for the manipulation of multiple waves in a way that wasn't possible before. So, what does this mean in practice? Well, for example, tensor holography could also be used in fields like architecture and design, where being able to visualize complex structures in 3D could help us create better buildings and products. And of course, there are endless possibilities for entertainment. Just imagine being able to watch a movie or play a video game in 3D without any need for special glasses or equipment. So, what's next for tensor holography? Well, the MIT team is still in the early stages of development, but they're optimistic about the potential of their technology. In their paper, they write that tensor holography opens up a new avenue for the exploration of holography, with exciting implications for science, technology, and the arts. And they're not the only ones excited about it. Other researchers in the field are already starting to explore the possibilities of tensor holography. Of course, there are still plenty of challenges to overcome. One of the biggest is figuring out how to scale up the technology. Right now, the MIT team's demonstrations are limited to very small holograms. But they're confident that with further research and development, they'll be able to create larger and more complex holograms. So, what does this all mean for the future of holography? Well, it's hard to say for sure, but one thing is clear: tensor holography has the potential to be a game changer. From medical research to entertainment, it could open up new possibilities for how we interact with the world around us. And who knows, maybe someday we'll all be walking around in a world of 3D holograms. It's definitely an exciting time to be following this technology, and I can't wait to see where it goes from here. Thanks for watching. If you enjoyed this video, don't forget to give it a thumbs up and subscribe to our channel for more content like this. See you next time.